Okay, hello dear students, welcome to Tejama YouTube channel. So I have started a new video series for KCET 2027 examination. So I will be making videos on each and every topic wise I'll be making videos, and wherein I will give the detailed explanation for the synopsis, and then I'll be solving the related and relevant PYQs as well as most important questions from that particular topic. So in this first video that I have taken from electric charges and fields, I'm going to explain or discuss about a new topic that is called charge. So let us discuss about it. So charge is a fundamental property of matter. Just like mass, charge is a fundamental property and it is a scalar quantity. Okay, do remember, in that we have two types, positive and negative. For example, if you take proton, it is positive, and if you take electron, it is considered as negative. Okay, then charge is always associated with mass. For example, electron is negative, still it has some mass, that is Me is equal to 9.1 into 10 to the power minus 9.1 into 10 to the power minus 31 kg, and proton is positive, it has a mass of how much, 1.67 something into 10 to the power minus 27 kg, minus 27 kg. So they are charges but still they have mass. So charge cannot exist without mass. This is very important. Next, the surety check of charge on a body is the repulsive, because a charge can attract a neutral body also. Let's consider charge on this is 0, but still a charged body can attract neutral body. Not only the charged body which attracts negatively charged body. Let's consider positive, negative. A charged body can attract neutral body. So what will be the difference? So in both the cases we have attraction, but repulsion occurs only if we have similar kind of charges on the bodies. Okay, next, charge is invariant. That means charge doesn't vary even if it moves at high speed. So then we have the SI unit of charge, that is Coulomb, but we have CGS unit and other units. So in CGS unit we have 1 Coulomb is equal to 3 into 10 to the power 9 electrostatic unit, and we have 1 divided by 10 electromagnetic unit. So smallest unit of charge is given by Franklin, that is equal to 1 ESU electrostatic unit, and largest unit of charge is Faraday, that is 96,500 Coulomb. Okay, so next one, the charge resides more at the sharp edges. For example, here if I consider an object like this, and if I give charge to this body, let's consider I have given charge, this more number of charges will go and accumulate at the corner, and less charge you can see in the less curvature area. Okay, this is how charge accumulates. They like the corners. So then we have the dimensions of charge, that is AT, because charge is given by current into time. So for current, dimension is A, for time it is T, that's why AT is the dimensions of charge. Then E is the basic charge, that is 1.6 into 10 to the power minus 19 Coulomb. Then we have the instrument used to detect charge on a body is gold leaf electroscope, or just we can consider as electroscope. So to detect we have gold leaf electroscope. What about measure? To measure the charge in a body we have electrometer. Okay, these are some basic properties about charges, but in the exam if they ask mention the basic properties, we have to write some other points that I will give. Before that, let us learn the 3-mark question that is very, very important for your board as well as competitive exam. That is methods of charging a body. Methods of charging a body. Let us discuss about it now. Yeah. So first one we have charging by friction. Second one charging by conduction, and third one charging by induction. In case of friction, what happens? You have to physically bring two bodies into contact. Let's consider here we have a body A, okay, which is rubbed with body B here. This is body B. So when they are under friction, that means one body is rubbed with another body, there will be transfer of electrons from one body to another body. Let's consider in this case the electrons get transferred from body A to body B. So because of that, what happens? Body A gains positive charge. The one which loses the electrons will become positively charged, and one which gains electrons will become negatively charged. Okay, one which gains electron becomes negatively charged. Because of that, mass of A slightly decreases and mass of B slightly increases, because electron not only carries the charge, it also carries mass of electron. So if n number of electrons are moving from one body to another body, they carry n into me mass to that body. Next we have charging by conduction. So if I consider here two bodies, this is body A and body B. So let's consider one body is charged completely. So another body is neutral, it is not charged. But by connecting a wire between these two, let's consider a contact. This is the conducting wire. What happens? Charge flows from one body to another body. Okay, then what happens? These two gets charged. That means charge from one body get transferred to another body. So here similar charge gets distributed. Because of that, after conduction they precede repulsion. So conduction precedes repulsion, that you should know. If Q1 is having more negative charge, that will be given to Q2. If Q1 is having more positive charge, that will be transferred to Q2. So and until what level it happens? Until they attain, charge transfer occurs until they attain same potential. Okay, so if we have similar bodies, two similar bodies, the charge after conduction is given by Q is equal to Q1 plus Q2 divided by 2. This is very, very important. And two similar bodies are brought into contact. Okay, now in the first case I had to tell one thing, that if a plastic rod is rubbed with wool or a cloth, what happens? It gains the negative charge, do remember? And glass rod which is given here, if glass rod is rubbed with silk or wool, then it gains a positive charge. Plastic negative, glass positive, that you remember. Next we have charging by induction. So here there will be no physical contact between the charged body and uncharged body. So how is that possible, sir? Let's consider here we have two bodies. This is body A, this is body B. Both are uncharged, but they are in contact. So I'll bring a charged body, but I won't touch that charged body to the uncharged body. A and B are uncharged bodies. So what happens here, if I bring a positively charged body, let's consider C near A and B, negatively charged particles, they move or get attracted towards C, and positive charges get attracted towards get repelled by C. So now charge A has got negative charge, charge B has got positive charge. Now what I will do is, I will first separate A and B. Okay, first I will separate A and B. Okay, this is A, this is B. The charged conductor still there. Now body A is having negative charge, body B is having positive charge. Then after that I will remove this charged body. So body A and body B, what happens? The charge gets distributed, negative charge gets distributed in the charge body A, and in the charged body B, positive charge gets distributed. Like this. Okay, this is called charging by induction, A, B. So what is the maximum charge induced, sir? Maximum charge induced in a body is given by minus Q 1 minus 1 divided by K. So here the charge induced will be opposite to the polarity of charged body. That's why we have got minus in here. So then this will be the expression for maximum charge induced. Because of that, here the induction precedes attraction. Okay, not repulsion. These two bodies can attract each other. Next we'll discuss about what is that, basic properties of charge. In this we have three types: charge is conserved, charge is quantized, charge is additive. Okay, so in case of charge is conserved, we have total charge of an isolated system remains constant. If I consider here, just a minute. Okay, so here we have the first property, that is charging by conduction. So here we have a body like this, in which we have few charges, like we have charge q1, charge q2, charge q3, minus charge, you can consider minus q4 also, q5 which is negative. Then the total charge is given by q1 plus q2 plus q3 minus q4 minus q5, like this. The total charge of the body will be algebraic sum of all the charges. Next we have charge is quantized. The total charge will be the integral multiple of basic charge. So that is q is equal to n into E for positive charge. If it has more number of negative charges, n negative charges, then it is given by minus n into E. Okay, so this is about charge is quantized. Total charge of an isolated system is integral multiple of basic charge. Okay, next, charge is additive. Can we add charges? Yes. So if you consider a body here in which we have charges like q1, q2, minus q3, q4, the total charge is given by the algebraic sum. In the first case we have added, just like that we can add charges and find in this charging by charge is quantized concept is very important for competitive exam point of view. Next we have some example questions. So here we have, how many electrons constitute minus 1 coulomb of charge? Since the data given, that is q is equal to minus 1 coulomb, E value we know, that is 1.6 into 10 to the power minus 19 coulomb. N value we need to find out because it is given how many electrons. So N is equal to minus Q by E So Q is minus 1 coulomb, that is given. E value 1.6 10 to the minus 19 coulomb. So minus minus get cancelled. 1 divided by 1.6 is 0.625. You can just remember this. Into 10 to the power plus 19, minus 19, if it comes to numerator, it becomes plus 19. So that is 625 into 10 to the power 18. And that will be the answer for this question. Moving on to next one. Yeah. So here a body has a charge of minus 3.2 microcoulomb. The number of excess electrons is, it is similar to the previous case, just use charge is quantized formula, that is Q is equal to minus Ne, because the charge given is negative, that's why I have taken minus Ne. So N is equal to minus Q by E. So that is equal to minus 1 minus Q value is minus 3.2 micro. Micro means how much? 10 to the power minus 6. So minus 6 coulomb divided by E value 1.6 into 10 to the power minus 19 coulomb. Coulomb get cancelled, minus minus get cancelled. If you divide, you will get the answer, that is 2 into 10 to the power 13. Option C is correct. Moving on to the next one. When a soap bubble is charged, its radius. So let's consider here we have a soap bubble on which charge is given. So when, let's consider positive charge is given, the charges get repelled each other. So charges get repelled. So to compensate that, what happens, along with the charges, even the surface increases, so that charges move away. Because of that, radius of this particular bubble has increased. So when the soap bubble is charged, its radius increases. Clear? Next, a positively charged glass rod is brought near uncharged metal sphere on an insulated stand. If the glass rod is removed, the net charge on the sphere remains same, or it will be 0, because initially it was uncharged, finally also it will be uncharged, because in induction process there will be no transfer of charges. Next we have, which of the following is not satisfied by the electric charge? Total charge is conserved or conservation, correct. Quantization of charge, correct. Existence of two types of charge, plus and minus, correct. But circular lines of force not possible, because electric field lines do not form closed loops. Okay, we'll discuss about in the concept electric field later. So that's why option D is the correct answer here, because they have asked for not correct option. When a body is negatively charged by friction, its mass, negatively charged means it has got more electrons. So slightly increases slightly, option B. So a particle of mass m has a charge q naught when it is at rest. When the particle moves with speed v, charge on the particle becomes q naught only, because charge doesn't vary doesn't vary when it moves. When it moves. Next we have, if an object x, just a minute, if an object contains x electrons, let's consider here it has x electrons, so charge will be minus x into e, and it has y protons, x electrons, so charge 2 will be plus y e, that will be the charge due to protons and electrons. The net charge on the object is given by, net charge is given by q1 plus q2, that is equal to minus xe plus ye, that is y minus x into E. That is option D is correct. Next we have, which of the following is not possible? First one is possible, second one is possible, third one is not possible, fourth one is possible, because here I have given the explanation. N is equal to Q by E from quantization of what is that? Charges. We have already studied Q is equal to plus or minus Ne. So N should be the integer. Okay, so N varies as 0, 1, 2, 3, so on like that. So if we take the Q by E, Q is given here, E we already know, take the ratio. For first option you'll get 10, second option will get 2, third option will get 0.1, fourth option is 5, so second option is not possible, that is 0.1 is not an integer, that's why option C, charge is not possible to have. Next we have 10 to the power 19 electrons are removed from the neutral metal plate. The electric charge on it is, so N value is given, N is 10 to the power minus 19 electrons are removed. That means the body gets positive charge. Okay, it is removed, electrons are coming out. So positively charged body we can consider. So first option is not correct. So N into E, N value is 10 to the power 19 and E value is 1.6 into 10 to the power minus 19. If you multiply, you will get 10 to the power, sorry, 1.6 as your answer. That is option B is correct. Moving on to next one. One metallic sphere A is given a positive charge, while the another identical metal sphere is exactly given the exact mass given the equal amount of negative charge. So B is negatively charged, A is positively charged. Which of the following is true? B mass increases. Mass of B increases because it is negatively charged. B has more electrons. A has more positive charges. So B mass is more. Option D is correct. Okay, next. Here we have unit of electric charge is Coulomb, which is equivalent to which of the following? Uh, so this is not there. Okay, which of the following? So charge is given by I into T. So for charge Coulomb is equivalent to ampere second. So option 2 is correct. So this is about this topic in this chapter. We'll meet you in the next video. Till then, take care. Bye bye. Thank you.